So you are supposed to match up the word with the corresponding like definition. So for circle, which one did you come up with? Okay, so a set of all points in a plane that are equidistant from a given point. Fantastic. What about tangents? A line that what? At exactly 1 point, right? Okay, so fun fact, here's my Latin background. So I took Latin in high school. They don't offer that here. Tangent, the root word means tango, which means to touch, which is why when you tango, you hold somebody's hand, right? Okay, fun fact. Okay, what about radius? Distance from a center point to the outside, right? Okay, what about a diameter? Bam, yes. Okay. What about a secant? Yes. And what about chord? Awesome. Do y'all have any questions about these words? You need to know like the definitions of these like back of your hand. Okay, now you don't have to use like proper terminology like that, but like know what they look like. Cool? Questions? Okay. All right, so today, and this is what I would write on my notes. Today we're going to talk about parts of a circle by identifying and defining chords, arcs, and central angles. Okay, so if I were taking notes, I would say circles, identifying chords, arcs, and central angles. That's what I would write on my paper. Okay. Again, if you're taking good notes, you want to date your paper. So it's 8/9 right now. Okay. And remember, I'm always going to have at least one video posted of the day. So right now, obviously I'm recording, but it will be posted on your eClass page. So if you ever go home and you're like, what the heck did that lady say? You can go back and look at it. Okay. All right, so let's go ahead and take a look at the first part. Okay. Okay, so the vocabulary term, and we're going to use the definition. So the set of all points in a plane that are equidistant from a given point are called the center of the circle. Set of all points in a plane that are equidistant. What do we call that? That's a circle. Okay, and y'all already told me a segment whose endpoints are the center and any point on the circle. You already know what this is. That's a radius. A segment whose endpoints are on a circle. That's a chord. And this is just kind of like a repeat of the last slide, most of these. Okay, a chord that contains the center of the circle. That's going to be the diameter. Okay, a line that intersects a circle in 2 points. That's going to be a secant. Oops, I can't spell. And a line, ray, or segment in the plane of the circle that intersects the circle in exactly 1 point. And this is a big one, point of tangency. You're going to want to know that terminology, point of tangency. So that's going to be tangent. Okay. Again, kind of a repeat of what y'all saw earlier. So sketch the vocabulary terms on the circle. Okay, so I don't think I can pull this over actually. That might be a lie. Oh, nope, there it is. Boom. Here's your beautiful picture of how I actually didn't draw this. Okay, so I know. Yeah, it's crazy. Okay, so really quick, let's go over this. Radius is from the center to the outside. Diameter cuts through the middle. A chord is just a line chilling that doesn't go through the middle. secant cuts in between 2 points. And so like here are the 2 points. I always was really bad with like secants. I don't know why. It always gave me trouble. I always forgot that word. Okay, cuts through 2 points. That's where we get the word scissors from. Yeah, kind of looks like the word scissors. Cut. And then tangent, here's our point of tangency. Okay. All right, so you draw a fabulous picture on your paper. So draw a circle, include all of that stuff, make it pretty. Yeah, the one on the right. All right, so let's take a look at the next slide. Okay, the images show some highlighted objects that are arcs and some highlighted objects that are not arcs. Okay, so which one are arcs and which one are not arcs? Well, yeah, it's labeled. It is labeled. So really quick, let's talk about the difference. This follows the circle, right? This follows the circle. This follows the circle. What does this do? Not follow the circle, it cuts through, right? Straight line, not an arc. Okay, what is this a picture of? What is this called? Quadratic. It's called a parabola. Fantastic. So, can you write a definition of an arc?
Yes.
Okay, talk me through it. What am I writing?
So basically a line that follows a circle but curves like that stops like at a certain point.
The curve of the circle. You're writing. Okay, so a line that follows the curve of a circle. Anything else we want to add to that definition? Because this is your definition. That's it. Okay. But does not cover the entire circle.
Yes.
Like it doesn't like completely enclose. Otherwise that would be a circle. Okay. Does not. You know, I say things and then I never write them out. Does not cover. You're yelling with your logic. Listen. It's fine. Line that follows the curve of the circle, but does not cover the entire circle. Does hot cover the entire. Listen. It's been a long day. I only got 30 minutes of sleep. All right, you ready for the next part?
No.
Write faster. Okay, ready? Okay, I'm going. I can come back if you need me to. All right, so this is an important one. It's important. Central angles. Okay? So here are the images of it. Okay, so central angles, they start from the middle and then they go out. Are you listening? Listen. Okay. In the middle and then goes out. Not central angles go and create like some weird angle that does not start in the middle. Okay, so writing our definition of this, angle that has a central point in the middle. Okay, and extends to the outside of the circle. Right, now if you wanted to write a better definition, that's fine. If you have like a shorter one, that's okay. Okay, central angle starts in the middle and then goes to the outside. Okay. Now, I want you to pay particular attention to this one. This is still a central angle. It looks like it's talking about the diameter, but you see how like they have this little like, whoop, okay? It's a 180. There you go. Okay, that can still be a central angle. Okay. All right, so recap really quick. We went over secant, we went over chords, we went over central angle, we went over arc, we've gone over what a circle is. Okay, all the things.
It doesn't have endpoints. Like when it does have endpoints, like when it does.
Okay, so would we consider a complete circle to be an arc? Y'all are saying no, because it wouldn't stop, right? Like there's not like any stopping points. It just continues going around, right? Okay. Also they're equidistant from the middle of the circle, right? Not that that's super important. Okay. What kind of segments? I want you to answer these two questions in your little group. What kind of segments make up a central angle? And draw a circle and draw 2 points on that circle. How many arcs are defined? So in your group, I want you to try it on your own, try to answer it, and then we'll talk about it in just a second. Okay. Get back. Okay. So what kind of segments make up a central angle? What did you come up with?
Radius
Two.
and
Okay. So everybody was like, oh. Okay, so radii, technically the angle is formed by rays that contain radii. So what's the difference between a ray and a radii? Do y'all remember? Closer. Say it again. There's a little bit of a difference. Yeah. They're very similar. Here, I'll show you a picture of it. Ready?
Isn't a ray keep going?
Ray keeps going
And a radius stops.
and a radius stops. Okay, good. So really quick. This is a ray. This is a radii or radius. Okay. Now, what kind of segments make up a central angle? 2 radii. Wow, look at those eyes. Okay. Now, draw a circle and draw 2 points on that circle. How many arcs are defined? So we draw a circle and then draw 2 points. Just let my circle live its best life. Okay. So how many arcs do we got? 2. Okay. Just let my circle live its best life, people. Okay. We define, okay, here's the next part. We're taking it up a notch. We define the measure of an arc as the measure of the central angle formed by drawing radii from the endpoints of the arc. I'm going to read that again because I know there's a lot of words. We define the measure of an arc as the measure of the central angle formed by drawing radii from the endpoints of the arc. Okay, so from here to here, we would say the measure of that arc. Okay. So when I ask for the measure of the arc, I'm asking for the degrees. Yes? That's what I'm asking for. So what is the measure of the highlighted arc from point C to D? Okay, so let's take a look at it. Hold on 1 second. From C to D, that's this part. How big is that angle? 60. Okay. What is the measure of the highlighted arc from D to B? Okay, how do y'all say 120?
Because it's half of the circle.
Half of a circle is 180. And then we already know that this is 60, right? So this guy's going to be 120. Y'all are so smart. Look at y'all. All right. What is the measure of the arc that goes from C to B to D? All right, so really quick. Okay, we're ready? Watch. C to B to D. So that would be 300 degrees. How do we know that?
Because the bottom part is 180 and then the B to D is 120. So you have that.
Okay, so we would, we would do 180 plus 120, okay? Or you could take, how big is a circle? 360 degrees minus this 60, right? That's how I probably would have done it. All right, what is the measure of the other arc that goes from C to B?
180.
Still 180 because that's half, right? Okay. When you're doing these kind of things, you want to make sure that you pay attention to the order that they listed in. So what I mean by that is if they say from D to B, you start at D and then go to B. Okay. Be mindful of which letter is listed first. Okay. And which direction they're talking about. Because if you would have put B to D, that would have been a different arc length, right? Or different measure. Okay. Got measure of an arc. Again, we're about to take this up a notch. I hope this is easy right now, though. No, what? Oh. All right. So let's talk just a little bit. We've got this partner talk task. We got this partner talk task. Okay, so I'm going to open this up really quick and I'm going to post it up on the board. Yeah, super fancy names, right? Okay, so decide who's going to be partner A and who's going to be partner B. So you're going to probably have like an elbow partner, just be partner A, partner B. If there's an odd number, just make 2 people partner A's. Sorry. Okay, ready? Okay, so you're going to read the task and individually record what you need to solve the problem. Then discuss the task together and come up with a group solution. And then we're going to repeat that process. I think it's 3 times. Okay, so here's your first one. Okay, I'll make this a little bigger. I know you can't see it. Okay, so partner A, you're going to do it on your own. Partner B, you're going to do it on your own. And then you're going to go discuss it. Okay, so on your piece of paper, I want you to find the values of X, Y, and Z. So on your paper, I would write this out as task 1. I would draw the picture, and then I would kind of solve it out from there. Okay, I'm going to give you about 5 minutes. Yeah, y'all are pretty quick. 5 minutes to do it on your own and then talk to your neighbor. But try it on your own first. Don't be like, yo, I don't know what I'm doing. Okay? All right, go ahead and get started. Pause this. Okay, so ready? Let's do whole group. Ready? Okay, so most of y'all probably got X pretty well. Okay, so let's talk about that. Okay, let's bring it in. Okay. Okay, so we got 20 right here. So X is going to be 20. Okay. Now, in order to figure out what Z is, we know that this line right here is a diameter. That makes this half of the circle 180. So in order to get Z, we're going to take 180 and subtract 20. So what is that going to give us? 160. Okay, now I would have taken 2 different answers for this one, but I'm going to tell you which one I think the correct answer is. So they asked us about Y. They really didn't tell us like how long Y was. Like, does Y go from here to here, or does Y go from here all the way to over here? Okay, so really quick, if you did it from this dot to this dot, then you should have gotten 160. Okay, but if you did it the other way, okay, you would have gotten 340. Okay, now your pictures on your test are going to be a little bit more clear than that. Okay, so don't stress about that. I apologize for that being a little confusing. Okay, so how'd y'all do on that? How many of y'all got those right? Even if you put 340 or 160. Okay, cool. Fantastic. All right, so let's look at task number 2. Okay, on task number 2, it says, given an example from the image of each kind of segment. So you're telling me which one is a diameter, a chord that's not the diameter, and a radius. Okay, so draw the picture on your paper and tell me which one is a diameter, a chord that's not a diameter, and a radius. Take 5 minutes, and then we're going to talk about it. All right, ready? Okay, so I'm going to do this pretty quickly. I'm going to show you all the ones that I came up with. Okay, diameter is like this one. Wow. Okay, so we got like G to H. We've got B to C, or you could say C to B. That's fine. Okay. And then you've got, for a chord that's not the diameter, you got D, E, and that's it, right? Okay. Radius is going to be A to C and A to B, A to H, or G to A. Okay. Normally with your radius, you want to probably list what the middle point is and then like extend it. So that would be like A to G instead, but it doesn't really matter. Okay. All right, we're gonna be on that last task. Last task. Ready? We got so much time. Okay, speed run. All right, last one. Ready? Lots of words. Last one. So the images show a circle with two congruent chords. Draw the central angles associated with the highlighted arcs from DD. Actually, you know what? We're gonna start with this as a warm up. Somebody remind me tomorrow. We'll start with a warm up.